Good afternoon, everyone. Thank you for joining me at this year's virtual fuel ethanol workshop. My name is Kevin Moore. I'm the Vice President of the Advanced Separation Group at Trucent. For more than 10 years, Trucent has been a leader in helping the industry extract corn oil as one of the key products in dry mill operation. We believe it's our mission to help the industry extract as much corn oil as possible. Today, I'm going to talk about the hunt for more corn oil, tips and techniques to help maximize your corn oil yields. I want to start out with a little bit of a market update, some of the history and some of the dynamics that we see coming. This first graph here is pricing of the three main products out of a dry mill, maybe in a format not typically presented. These are all in dollars per ton. And you can see for the past 5 years, corn oil has enjoyed the highest value of any of the products coming out of a dry mill. Important here, of course, is the delta between corn oil pricing and DDGs. For the past couple of years, that delta has averaged about $360 a ton or 18 cents a pound. That is higher value, much higher value for the corn oil. So significant incentive to continue to pull more and more corn oil out of DDGs. This graph here, taken from the USDA, when I put this presentation together, this graph surprised me a little bit, actually. The flattening of the DCO output over the past couple of years, still approaching 4 billion pounds annually. Our yields are up as an industry to about 0.8 pounds per bushel. One of the important things to note, though, is that compared to the amount of corn oil that comes in with the corn, we still have a lot more to go. When you use the 2019 yield of 0.77 and the 1.9 of the corn oil coming in with the corn, we're actually, as an industry, only extracting about or only recovering about 40%. That means we're leaving behind about 6 billion pounds a year in DDGs, which has a value, a gross value using 25 cents a pound for corn oil of about 1.5 billion pounds a year, $1.5 billion a year that the industry is leaving on the table or leaving in DDGs. A lot of detail on this chart here. One of the drivers that we see for corn oil coming over the next couple of years is the capacity build in renewable diesel. As shown in this chart, current output for the industry is about 400 million gallons a year. Within the next couple of years, though, there's an extra billion gallons of capacity coming online. Those extra billion gallons are going to require about 8 billion pounds a year of feedstock in order to supply those facilities. Notable here on this graph are the major players that are investing. These are very expensive plants, hundreds of millions of dollars, if not billion-dollar type investments. And you see the big petro players, Phillips 66, Marathon, Valero as a partner in Diamond Green Diesel. Probably also notable here, Valero in their second quarter reported margins in their renewable diesel portfolio of almost $1.80 a gallon. Again, that's margin, that's not selling price. It's that margin that, of course, is driving this investment in renewable diesel to support the various low carbon fuel standards that exist now predominantly in California, West Coast, and other areas. So a lot of capacity coming. This capacity is of course driving concern on the feedstock side. Headlines from various publications over the past year or so questioning where the renewable diesel players are going to get their feedstock. Corn oil certainly figures prominently in the calculations in the need to support this building boom. The renewable diesel players that I've spoken to have indicated quite clearly that they are looking at distillers corn oil, looking at DCO as an important feedstock supply for their capital investments. Notably here, also important, again, carbon intensity score in support of the low carbon fuel standard is an important driver in the consideration of feedstock. Corn oil enjoys a pretty favorable CI score, particularly compared to other processed oil, soybean oil, canola oil. Not quite as good as reused or reused oils. But again, at the 30 range, corn oil is going to be secured as a feedstock in this build. So as a summary of the market dynamics, we have high value, check. We have more available within your dry mill, within the industry, more available to recover, check. And we also see significant demand pool coming, check. So let's go hunting. This is a schematic, a simplified schematic of a dry mill process that all of you will recognize. At Trucent, we focus on two pretty important forks in the road when we look at determining options for improved corn oil yield. We look at the decanter, which of course is the first fork, and the oil that goes out with the wet cake is oil that is not presented to the oil extracting centrifuge. So that's an important measurement. And then of course, the recovery at the corn oil extracting centrifuge itself. For the balance of my talk, I'm going to focus more on the latter, more on the extracting centrifuge. That of course is where we have the majority of our experience. For discussion around the decanter, I would say stay tuned. We will have something to say about that soon. We at Trucent have been performing an industry report card for several years now. This data, as presented, is based upon our customer base and our surveys of those customers. Again, when you look at the amount of oil coming in with the corn, average 1.9. The split at the decanter ranges from a low of 45% to a high of 70%, with 60 being the average. And that is the amount of oil that goes with thin stillage. And then at the corn oil extracting centrifuge, we have seen an improvement in this in our customer base, an uptick in both the average and the leader chart of a few points. At Trucent, we focus on being guided by science in our separation efforts. In this case, we are guided by Stokes' Law. So also our guide in this hunt for more corn oil. I'm going to focus on a few parameters in this equation, notably the centrifugal acceleration. How fast you spin your machine is an important driver. I'm going to talk a bit about viscosity. Viscosity, of course, is an impediment to separation. And then also on D squared, that's the diameter of the oil droplet that you are trying to separate. Because it is a squared function, you get an extra bang for your buck if you're able to increase the size of your oil droplets. This here is a picture of our offering, our centrifuge technology offering to the industry. This is a high-speed centrifuge on an engineered skid. We now have over 80 of these deployed across the industry in more than 40 ethanol plants. Over on the right is our lab results, time at 6,000 Gs, which show that you can overfeed. You can have a situation in which you don't have enough residence time in these machines. And we have real world experience in this in plants in which customers that have added a skid have been able to cut their flow rates down, their average flow rates down across their skids, more residence time, and has resulted in more oil output and payback on the additional machine investment. I consider this to be one of the more important slides, maybe the most important slide in my presentation. These are pictures of conicals, of spins on the heavy phase off various machines. Many of you in the industry perform these as well. You'll recognize this. You take a sample of your heavy phase, you spin it on a lab centrifuge, a benchtop centrifuge, and you look for an oil level, an oil layer. We almost never see any oil in these spin tubes. Maybe some of us would take comfort in not seeing any oil. You think your machine's performing just fine. But our recommendation is to actually measure the amount of residual oil in your heavy phase, because there's not a correlation. We have not seen a correlation between residual oil and oil layer. And we see across the industry, residual oils, almost non-detectable to as high as 1.4%. And subsequent efficiencies or yield across the machines from a low in the low 70s to a high in the high 90s. For us, it's really important to measure this amount of residual oil in order to understand where we have opportunities for improvement. One of the pieces of equipment, one of the technologies that we introduced to the industry a couple of years ago is a continuous rotary strainer. This system, this piece of equipment is actually installed in front of our COS machines, in front of our centrifuges, has been from the beginning. But what we discovered is that with the right size screen and in front of competitor machines, competitor technologies, we can actually see a significant viscosity reduction and a subsequent improvement in oil yield. Good payback on this investment. Fundamentally, what we are doing is removing the large particle sizes that can interfere with separation. Again, we get viscosity reduction and oil improvement, oil yield improvement. At last year's FEW, we introduced our Ascent deemulsification technology. This was a multi-year effort. We had for a long time been investigating and partnering with other chemistry suppliers. In this case, we have partnered with Croda, a large surfactant company, a long time specialty chemical surfactant company. And we traded samples and results back and forth over the period of about a year. We investigated more than 25 different chemistries from Croda and selected what we believe to be the most powerful surfactant, custom designed for corn oil recovery, as opposed to polysorbate 80, which was effectively pulled off a shelf and tested and found to work. So our chemistries are non-polysorbate based. We support those with sampling and process analytics. It is, of course, GRAS certified and patented. Since last FEW, we have actually rolled out a family of Ascent products. We now have 5 commercial products. One of our learnings over the past year is that other ingredients, other blends based upon our original Ascent chemistries have additional power or can improve the separation. And in these case studies where we are selling product, you can see that we've been able to generally reduce the amount of deemulsifier that the customer was using and seen significant oil improvement. One of our learnings is that today we don't have a predictor of exactly which chemistry is the best for your plant or location. So it is our practice to trial syrup samples that we receive, determine the best 1 or 2 products within our portfolio that work the best, and then get out for a trial. In our history in supporting the industry, one of the things that we've done that we did several years ago was an investment in our own analytical techniques in support of the industry. We just weren't satisfied with sending samples out to other outside analytical labs. The sample complexity of the syrup streams, the various components in those required us to develop, to do a fair amount of work in accuracy in order to properly understand material balances. And so we've got those, we've got that full service lab that supports our customers in the industry in understanding their corn oil numbers throughout their process. We do leverage that lab and those techniques with support for customers for a program that we call Oil Tracker. This is a program in which we work closely with partner plants, with customer plants, work with staff, train them on our knowledge, pull samples, run material balances. We provide customized and regular reports. And we provide recommendations for process changes to increase oil recovery. So in summary, my hunting advice is that, first of all, measure the oil in your heavy phase. The simple spinning of centrifuge tubes and looking for an oil layer is not enough. Second, look for mechanical enhancements that could improve your separation efficiencies. Use the best emulsifier in your process. There's no one size fits all when it comes to an emulsifier. And then Trucent is happy to be your guide in the hunt for more corn oil. That concludes my talk for today. Thank you for participating. Thank you for listening to me. And please reach out if you've got any comments, if you've got questions about corn oil recovery in your process and would like to get more. Thank you.